All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answer. So for the factoring, you should have x plus 10 times x plus 10, or x plus 10 squared. Okay? For the math knowledge question, they give us all this information, and we're going to skip down here. It tells us we have 510 students, and instead of selling something, we can donate $3 to a goal. So if 80% of them donate, how short will we be of our goal? So the total number of students that we have is 510, and if we multiply that by 80%, that'll give us 408 students. And so if each of them gives $3, that would get us to 1,224. And so we need 1,250. So 1,224 over 1,250 as a percentage is 97.9%, which rounds to approximately 98%, because it says to the nearest whole percentage. So we would be about 2% short of the goal. Okay, so that's how that one would work. So we are looking at lesson 45 today, Introduction to Coordinate Proofs. So hopefully after this lesson you'll understand how coordinate proofs work. We have already looked at algebraic proofs, two-column proofs, flowchart proofs, and paragraph proofs. And these are a different kind, and they're not as involved as some of the other ones. I think these are a little bit more straightforward, a little bit easier to handle. So we have a rectangle, has a length of 5 and a width of 3. We want to position it on the coordinate plane, and it only tells us we have a rectangle, the length is 5, and the width is 3. So you can put it anywhere on the coordinate plane. It doesn't matter. You can put it over here, 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 wherever you want. So why don't y'all try that? The best place to put it is going to have one vertex on the origin. You don't have to, but that's going to be the best place to put it. So if y'all did that, that's good. It's going to make it easier whenever it comes time to actually work with your drawings on the coordinate plane. So that's the one that I did. You do need to label your vertices, and it has a length of 5 and a width of 3. Okay? So a coordinate proof is a style of proof that uses coordinate geometry, and you're going to use algebra. In a coordinate proof, you're going to have a diagram, and it's going to be placed somewhere on the coordinate plane, like what we just did. You'll have to put something on your graph. They can be placed anywhere. Doesn't matter where, but it's usually easiest to place on one side of an axis or to place one vertex at the origin. So on our graph, we actually had two sides of our rectangle on the x-axis and the y-axis, and we had a vertex at the origin. It's just going to make your math easier if you do that. So here's an example of a triangle on the x-axis and at the origin, like a rectangle, like we just did. You could also do it where this number and this number are the same. They're both equidistant from the origin. Or you could put a triangle here. But it's going to be easier if you have at least one vertex at the origin. So we want to use a coordinate proof to show that the triangle is an isosceles triangle. So we have our graph already drawn for us, so we don't have to do it. All we need to do is prove that two of the side lengths are congruent. So if we use the distance formula, we can find the length of LM pretty easily without even using the distance formula. We can just count 1, 2, 3, 4. And then if we want to find the distance of Ln, you're probably going to want to use your distance formula. So x2 minus x1 squared plus y2 minus y1 squared, which would be 2 squared, 4, and 4 squared, 16, which is the square root of 20, which if you simplify that is 2 squared roots of 5. And then we can find the distance of Mn. And so again, you're going to use your distance formula. So we're going to have 4 minus 2 squared and 4 minus 0 squared. So that would be 2 squared, 4, and 4 squared, 16, which is square root of 20, which does reduce to 2 squared root of 5. And so those are the side lengths of your triangle. And so for it to be an isosceles triangle, at least 2 of them have to be the same. So since side Ln is congruent to side Mn, triangle LMN is isosceles. Okay, so that's how you can do a coordinate proof. Basically, you're just going to use information on your graph, and then you're going to do some algebra to show the information that they want you to prove. So that's all you have to do. Okay, so looking at this one, we want to put a square that has side lengths of t on the coordinate plane and label each vertex with an ordered pair. So y'all pause the video and try and do this one by yourself, and then unpause it and I'll go over what your answers should look like. Okay, so if you're going to put it at the origin, that would be best, but you don't have to. And then you can put them anywhere. It doesn't matter, we're just making a square. And so this vertex here at the origin would be 0, 0. And probably messed up on this part. This side, you're not going to put like 5 or 6 or whatever number you went over. You're going to put t, because it said it has a side length of t. It didn't tell you to make a value for t. So y'all probably put a number there, and that's a common thing. That's okay. I wanted you to try it by yourself to see if any of y'all would get it right. This point would be 0t, and this one would be t. And so that should be what it looks like. If you didn't put it at the origin, then you're going to, like if I put it over here for one vertex and that one for another one, you would have to do 1, -8. And then I went over 1 plus t, and then down -8. And then for this point down here, it would be 1 and then -8 minus t, because we went down another t. And then this point would be 1 plus t and then -8 minus t. So that looks a little bit more complicated than just using these. And if you'll put it on the x-axis and y-axis and at the origin, it'll make it a lot easier. Okay, so let's try another one. Y'all try and do this one by yourself. Pause the video and then I'm going to go over it for you. So we're going to draw a parallelogram. You want one vertex at the origin, if at all possible. And if you get this right, that's awesome. I'm not expecting you to get them right off the bat. We're practicing these. I just want you to try them by yourself first. So 0, 0 would be the first one. And it says one side is labeled K. So this length is K. So we'll go over K and then up nothing, because we're on the x-axis. And then this one right here, we went over a certain amount and then we went up a certain amount. And I don't know how much either one of those are. So I'm just going to say A and B. I made up A and B. Okay, and then this one, we went over K and then we went over A, because that's the same distance as going over this part. So we're going to go over A plus K and then we're going to go up B. So that would be the answer for that one. It should look something like that. So again, you shouldn't have numbers because it didn't give you any numbers on this one. Let's try this next example, see if you can do it by yourself, and then I'll go over it. Alright, so for this triangle, there are actually a couple of different ways that you can do it. I'm going to go over one, and then I'll try and hit the other ones, and you may have it correct, and it just not be one of the ones that I show. But there are several different ways you can do this one. It says it's an isosceles triangle, and it has a height of 6 from the origin. So that means that it's going to have a vertex at 0, 6. And then it could be a right triangle, an isosceles right triangle. And so that could be one option. That's an isosceles triangle with a height of 6 from the origin. Another option this point is still going to be 0, 6. I could go over some amount on both the left and the right hand sides and make a triangle like this. And so you could have negative x 0 and x 0 because we don't know how far left and right it would go. So either one of those would work. If you have something else, y'all can check with your neighbor and see if maybe they agree with you. But those are the two most common ones for this one. Okay, so now we're going to look at this example. Prove that the diagonals are perpendicular to one another on a square. So we're going to start off by making a square. And this vertex would be 0, 0. This one would be, we'll do t, 0. This one would be 0, t. And then this one would be t, t. So diagonal, we're looking for the slope here because we want to know if they're perpendicular. So the slope for that one would be t minus 0 over t minus 0, which is t over t, which is 1. And then the other diagonal, we would have t minus 0 over 0 minus t, which is t over negative t, which is negative 1. And 1 times negative 1 is equal to negative 1. So the slopes are perpendicular. So that's all you have to do there. Just find the slopes and show that they multiply to give you negative 1. Okay? Looking at another example, we want to show that the wading pool has a surface area that is 3/10 of the larger pool surface area. So let's first find the area of the larger pool. That's going to be this part here. And so area of a rectangle is going to be the length times the width. So this is m times n. So area of the larger pool is m times n, which is just mn. The area of the wading pool, 1/2. The base is here. So I'm going to erase this red part, which that point is 3/5 m. So our base length is 3/5 m. And then the height, it goes down to negative n. So that's just an n because the distance is a positive number. So if you multiply 1/2 times 3/5, you get 3 over 10, and then mn. And so, therefore, wading pool is 3/10 times area of the larger pool. So that's how you could show that one. Mainly just have to do some algebra to show your answers for these. Alright, so let's see if y'all can do this one by yourself. Y'all pause the videos and then I will go over it. So we want to put a right triangle with leg lengths of 2 and 6 so that the legs are on the x and y axis. So it didn't say whether to put the 2 on the x or on the y, so it doesn't really matter. But I'm just going to go up 2 and I'm going to go over 6. And so there's my right triangle. And we want to label the vertices. So this would be 0, 2. And this would be 6, 0. And then 0, 0. And so that would be how that one works. Okay, looking at this next one. We want to prove it is an isosceles triangle. So y'all try that by yourself and then I will go over it. So the distance of JL, if you count over, it goes over to 2. So it's just a distance of 2. The distance of JK, if you use your distance formula, you would have 1 minus 0 plus 1 minus 0. So 1 squared plus 1 squared is square root of 2. And then the distance of the third side, KL, we would do 2 minus 1 squared plus 1 minus 0 squared, which would be 1 squared plus 1 squared, which again is square root of 2. So JK is congruent to KL. So the triangle JKL is isosceles. And that would be your proof for that one. Looking at this next one, y'all see if y'all can try it by yourself and then I'll go over it. We want to put a right triangle on the coordinate plane, so I think it's best to put your right angle on the origin so that we have 0, 0 for one of our vertices. And then it says one leg is A, so I went over A and then I went up B, so 0, B. So that would be an example. You could have these 2 points switched. The A and the B could be switched. It didn't tell you where to put those. But that would be the easiest way to do that one. Okay, now we want to prove that this is a parallelogram. To prove that it's a parallelogram, we just need to prove that the opposite sides are parallel. So side UV slope is 0 because it's a horizontal line, and side TW is horizontal, so its slope is 0. For UT, the slope would be 1, 2, 3, 4, 5, 1, 2, 3, so negative 5 over 3. And then VW, 1, 2, 3, 4, 5, 1, 2, 3. So since opposite sides are parallel, PUVW is a parallelogram. So that's really all you have to prove on that one. Okay, so now let's look at this one. We have a yield sign that's an equilateral triangle. Use the vertex as the origin as one of your vertices. find the coordinates of the other vertices in terms of m. So one of them would be easier to put here. It says it's equilateral, so that means that we're going to have to do something like this, because there's no way for it to be a right triangle and be equilateral. So this vertex would be 0, 0, and it wants us to find this one and this one. So the other one would be M0, and then we need to find this vertex up here. So I'm going to come over here. We know the length of this side has to be equal to M. This is a right angle here, and then this is half of M. So we're going to use Pythagorean theorem to find the height here. So 1/2 M squared plus h squared equals m squared. So this would be 1/4 m squared plus h squared equals m squared. And then if you subtract, you get 3/4 m squared. And then take the square root of both sides. And your height will be the square root of 3. We don't know how to reduce that. The square root of 4 is 2. And then the square root of m squared is m. So the other vertex would be 1/2 m, and then square root of 3 over 2m. So that's how you would do that one. So hopefully you got most of those correct by yourself. Now we're going to look at our challenge question. We have the vertices of our parallelogram. We want to calculate the coordinates of the vertices of a similar and larger parallelogram with one vertex still at the origin, and the similarity ratio of the two figures is 3. And then you want to confirm your answer by assigning values to your variables and drawing two similar parallelograms and calculating the lengths of the sides. So I'm not going to actually draw them out and calculate the lengths of the sides or assign values to your variables. I'm just going to tell you what you would do with your vertices. So one of them is going to still be 0, 0. The other vertex could be 3 times A, 3 times B. Another one would be 3 times A plus 3 times C, and then 3B. And then the third one would be 3C and 0. You're just going to multiply everything by 3 because that's your similarity ratio. And then you can draw them out and actually calculate it to confirm it. But those would be your vertices that you would have. So hopefully y'all got those right. Your homework tonight is 1 through 30. So let's make sure we do those tonight so we can go over your questions tomorrow.